Hi, I'm Batmavati. This video is about the methods of debugging in Visualsim. Generally, in debugging a model, we have two steps: figuring out where the bug is and figuring out how to fix it. We'll focus on the first step since that is what normally consumes most of the time. We understand something is wrong when the model throws an exception or a value being displayed is not the desired value. And later we could realize that the bug is not at the point of display but rather at some point where the value is calculated wrongly. We need to find that point to fix the error. So debugging proceeds from the point where we realize the error to the point where the error was actually introduced. Debugging in Visualsim. In Visualsim, the debugging process is more tractable, that is, tracing backwards to the source of error. It is a graphical modeling environment that has unique debugging models. So it has methodologies, many graphical and textual debugging features built in, which resolves many model inconsistencies, approaching 95% of the bugs. These are the graphical and textual debugging features available in Visualsim. We'll see some of the features in this video. Model construction strategy. These are the strategies that you can follow while constructing a new model, in which debugging is also done parallelly along with the construction, which avoids bugs at later stages. In this model, you can see a number of hierarchical blocks at the behavioral flow and an arm system, accelerator in the main model. So these are individual subsystems integrated into the main model. So before integrating into the model, you can create the subsystem as an individual component, check the flow, and if there is any error, you can fix it. So it is like building your model incrementally in step by step and saving each function as a class or hierarchical block. So by this way, you are testing small sections of your design before adding it to the top level, which will help you in reducing most of the bugs at the model completion or simulation stage. Also use the displays and debug statements while constructing the model to test accordingly. When running the model, if there is any error with the configuration of the block, an error message will be shown, and the block with error will also be highlighted. So the error message provides you an error description which using which you can find what is the error and where it occurs. In this model, you can see a traffic generator that generates data. It passes through a delay block and the result is being viewed. So now if I run the model, we get an error message saying the block name. The block name is delay. So the error is with the delay block. And the description shows that the ID delay time is undefined. You can see a brief description here. So it means there is some error with the delay block. You can also see that the block is being highlighted. So it helps you to figure out where the error is occurring. The error message also gives you the solution, like the delay time is undefined. So it is not mentioned as a parameter or variable in the model. Data flow. To see the correctness of the field values and the functions, you can use the listen to port, listen to block, and you to verify the whether the data is coming from the right source and reaching the right destination, to check the transaction ID, and you can use the data structure fields. Animate execution. This is one of the features of debugging in Visualsim, which will show you where the data is flowing in the model. That is the dynamic operation of the model. The block which is executing will be highlighted, and you can specify how long the block should be highlighted. Also, the animation can be passed, and then either you can start the simulation, stop, or do other debugging operations. Here we have the data that passes through the queue block server, then accessing the system resource. So now if you run the model, there is nothing displayed in the text display. So there is some bug in the system. We need to find where it occurs. So you can animate your model. To animate, go to debug and select animate execution. So this is here you can mention the time for how long it should highlight. It is in milliseconds. So it will highlight for 250 milliseconds. Then select OK. Then now if you run the model, you can see the data, how the data is flowing. First it comes from traffic generator and the data is reaching the queue block. You can see every data is coming to the queue block, but it is not reaching the server block. So the possibilities may be the uh, pop is not arriving, or it is taking too long to reach the queue. So this is how you figure out where the error occurs. To stop the animation, go to debug and select stop animating so that you will return to the normal running mode. Text display, plotters, and statistics. These blocks are used to find the error in the behavior of the model. The text display block displays the data coming to its input port. It may be anything like the data structure, integer, etc. The plotters are used to display the latency, throughput, graph of any values. Also, the statistics blocks generates the statistics like buffer occupancy, utilization for the hardware, and the functional blocks. Architecture setup generates for hardware components, and the resource statistics for behavioral blocks. So first let's see how the plotters helps. So in this model, we have a traffic generator. The data passes through the network through the transmission channel, and the latency across the network is calculated at the end. So here you can see when running the model, we get the latency plot. Now you can see the latency is high for some data. You can see the value here. For some data, the latency is high. So you will come to know that there is some congestion or delay in the network or any system. Next, we'll see how the resource statistics helps. So in this model, we can see how the data is flowing. So here you get the detailed statistics for the queue block and the server block. So if you see here, we have the number of packets entered, number of packets exited, and the number of packets rejected. So the number of packets entered is 114, and no packets exited the block, and 84 packets are being rejected. So this shows that the buffer length is not enough for the packet, or the traffic rate is high, or the pop is taking too long to arrive, or it is not arriving the queue block. And for the server block, you can see there is no packets coming to the block. Also the utilization, you can see the utilization of the block here. So it shows there is some bug with the queue block. So you need to change the traffic rate or buffer length or the pop. You need, this is how you can figure out where the bug is with.